So number 31, we've got these two planes converging. So one plane, which I'm going to call the distance here x, they're going to meet at this. Whoops, didn't want to do that. They're going to meet at this point here. So that's going to be x right here. And this will be y. And the distance between them will be s. It says that one plane, the one here that's traveling horizontally along x, is traveling at a rate of 450 miles per hour. The one that's moving in the y direction's moving at 600 miles per hour. So those are rates, those speeds. So that's dy dt and dx dt respectively. They want to know at what rate is the distance between them shrinking. So they want to know ds dt. As these planes move, all three sides are variables. So when I do my related rates equation by taking the derivative, I get this guy. So x, they tell me that is 150 miles out. We want to freeze it when x is 150, and dx dt is negative 450. Y, they tell me, is 200 feet away, and dy dt is negative 600. So s, by Pythagorean theorem, would come out to be 250 when I do Pythagorean theorem with 150 and 200. And ds dt is what we want to know. So I solve for ds dt. So I will bust out the trusty calculator. This is negative 135,000. 600 times 400 is 240,000, and this is 500 ds dt. So it's negative 375,000 equals 500 ds dt. Divide by 500. And I get negative 750 miles per hour. That's the rate at which the distance is shrinking between the two planes. Eventually, when that distance gets down to 0, they will crash. So part B says, how much time does the air traffic controller have to get one of the planes on a different path? So we need time. So we know that distance equals rate times time. And we're looking for time. So you can pick any one of these planes and use their distance and their rate until they get to that point. So I'll use this guy here. He's at a distance of 150 miles. He's traveling at a rate of 450 miles per hour. How much time does the air traffic controller have? So when I do that division, I get negative 1/3. In this case, the negative isn't a big deal. I'm talking about a rate. Direction doesn't really matter, so I could use an absolute value here, which would make that positive. But that means they have 1/3 of an hour, or 20 minutes, until those planes meet.